Evolution by the stages. A question that arises here is if the complicated organs, okay, such as eye, are selected for the advantages they provide, how can they can generated by the single DNA changes. Okay, how it is generated if a single DNA are changes. Okay, then also we can see that some of the characteristic of our eyes are changing. Surely such complex organ will be created bit by bit over generation. Okay, generation by generation, what we are saying, a complex organism can be created, and that are little bit difference. Okay, they have a certain difference or a characteristic from its parent generation. Okay, so but how can each intermediate changes be selected for? Okay, once we can see that, okay, a parents, okay, from the parents it get transmitted to its daughter or son generation. Okay, but then also we can see that some of its newborn baby containing generation have a certain variation in its organs. Okay, some of its organ we can see that there is a little bit of variation. Okay, some of them containing eyes are different from its parents. Okay, because of both the parents, okay, characteristic are transmitted to that particular son or daughter generation, and there are a number of possible explanations. Even an intermediate stage such as a rudimentary eyes can be useful for some extent. This might be enough to give a fitness advantages. Okay, fitness advantage, for giving a fitness advantages, this is sufficient. Okay, in fact, the eye, like the wings, the eye, like the wings, seems to be a very popular adaptation. Insects have them. So does an octopus, and so do vertebrate. And the structure of the eyes in each of these organisms is different, enough for them to have a separate evolutionary origin. Okay, if we talk about the certain animal as well as birds, okay, all of them contain a different variation in its eyes. Okay, all of them contain a different type of eyes, and that will make them to differ it from each other, and they will get a separate evolutionary origin. Okay, they have a separate origin of its evolution, and they will get a different species. Okay, they will provide it a different species. Okay, so from that we can see that all the animal as well as birds, okay, will not contain a equal amount or the same characteristic eyes. Okay, they have a certain difference with each other, and due to which that difference will make them differ from each other. Okay, the difference which are making with each other or we are getting with each other, that will make them differ from each other. Okay, so this was the evolution, how the evolution can take place by stage by stage. Okay, we will study that only. Here you can see that, okay, so you can see that same way. Here you can see that this is the small dinosaur from the dromaeosaur family. Feather imprint were preserved along this dinosaur's bone. Here we can see feathers on the forearm. Okay, so in both the cases you can see. Also, a change that is useful for one property to start with can become useful later for quite a different function. Okay, one change also make them useful for that property. Feathers, for example, can start out as a providing insulation in cold weather. Okay, when it was cold weather, it will insulate it. Okay, but but later they might become useful for flying. Okay, further on, it is also useful for flying. Okay, in fact, some dinosaurs had feather, although they could not fly using the feather. Okay, dinosaur, okay, which are containing feather, okay, then also they cannot able to fly with their own feather. Okay, why? Because they have a different characteristic with the comparing with the other animal or birds. Okay, so all the birds and animal have its own characteristic and specialization, okay, which are very useful for them, and that will make them to differ it from other. Okay, so that is the important characteristic or a specialization which will make them differ from each other. Birds seem to have a rather adapted the feather to flight. Okay, here we can see that birds which are having feather, they will use it for flying. Okay, so that is one of its characteristic, that birds are using their feather, okay, for flying. This, of course, means that birds are very closely related to reptile, since the dinosaur were reptile. Okay, from that, if we compare a dinosaur and a birds, okay, we can see that both of them contain a feather. Okay, so that is the one of its specialization of a bird, that they can use their feather for flying, but dinosaur cannot able to use for flying. And here you can see that dinosaur, which is one of a reptile, okay, that dinosaur or a reptile, okay, class is compared with the bird, okay, with the birds, which we say it is aves, ave, use. Okay, so birds, it is compared with the birds, and it is one of its characteristic that birds and dinosaur, both of them contain a feather, but dinosaur cannot able to use it for flying, but bird can able to use. Okay, it is also very well to say that very dissimilar looking structure evolved from a common ancestor design. Okay, it is interesting that dissimilar looking structure, okay, evolved from a what, okay, common ancestor design. Okay, dissimilar looking structure, okay, both of them are totally dissimilar with each other, then also they are evolved from what, okay, they are evolved from a same ancestor or a common ancestor design. Okay, so it is interesting that both of them contain a totally different similarity, okay, do not have a similarity, a single character, then also they are evolved from a common ancestor, okay, design. It is true that analysis of the organ structure, okay, analysis of the organ structure in fossil allow us to make estimate of how far back evolutionary relationship go. Okay, so analysis of a organ structure in the fossil also allow us to make what, okay, to estimate how far back, okay, from which stage or from which period, okay, it is belonging. Okay, that is evolutionary relationship. From that we can judge it, that how much old that organism are deep or buried. Okay, that organism are buried, but those are guesses about what happened in the history. Okay, so from that we can just guess it that this should be there, okay, in a history. Are there any current example of such processes? Okay, that are one of the what? Okay, that are one of the thing or a guesses that can be established that this can be there in the ancient time. Okay, so current example of such processes, the wild cabbage. Okay, if we talk about the wild cabbage plant is a good example. Okay, wild cabbage, okay, which we take as example, it is the good example. Human have over more than 2000 years, okay, cultivated wild cabbage plant in a good example. Human have over more than 2000 years cultivated a wild cabbage as a food plant. Okay, if we talk about the human will take like how many 2000 years ago cultivated a wild cabbage as a food plant. Okay, from the before 2000 years, okay, we are using a cabbage as a food plant, wild cabbage. Okay, so, and generated a different vegetable from it by selection. Okay, different vegetable are selected depending on them. Okay, or selecting them. This is of course artificial selection rather than natural selection. Okay, it is mostly artificial only. Okay, but naturally also some of them are there, but artificially it get generated and it gets selected. So, some farmers have wanted to select for very short distance between leaves and have a breed the cabbage we eat. Okay. So, what the farmer wants select a very short distance between leaves. Between leaves there is only a little bit of distance are there and have a breed the cabbage we eat. Some have wanted to select for the arrested flower development, okay, and have a breed broccoli, okay, broccoli, or for the sterile flower and have made the cauliflower. Okay, for making a cauliflower, okay, from the cabbage, okay, it get generated, okay, by evolution. Okay, due to evolution, okay, from that we can say that cauliflower are maintained. And some have selected for the swollen part and come up with the kohlrabi, okay, which is one of the thing. Some have a simply look for the slightly larger leaves and come up with the leafy vegetable called curly. Okay, so leafy vegetable are said to be curly. Okay, as well as you can see that some of them have selected for the swollen part. Okay, and come for the kohlrabi. Okay. Would we have thought that all these structures are descended from the same ancestor if we have not done it ourselves? Okay, if we are not doing by ourselves, okay, they all of them contain the same ancestor. Okay, so here you can see that, okay, wild cabbage, okay, from that curly. Okay, from the wild cabbage, okay, you can see that curly, okay, whole maybe, okay, from wild cabbage also you can say that broccoli as well as cabbage. Okay, then it is one of the red cabbage, okay, which are very famous in this time, as well as cauliflower. Okay, so all of them, 1 2 3 4 5 and 6, okay, all of them contain a common ancestor. Okay, so from this we can see that all of them contain what? Okay, common ancestor, which we say it is a wild cabbage. Okay, and many more, okay, of them are there. Okay, so from this we can see that all these things, okay, which are there, okay, having a common ancestor. Okay, all of them contain a common ancestor. Okay, now another way of tracing a evolutionary relationship depend on the original idea that we start with. That is, the idea was that change in a DNA during the reproduction, okay, it can although, okay, although it can be seen that evolution can also be seen by changing a DNA during the reproduction. If that is the case, then comparing the DNA of a different species should give us a direct estimate of how much the DNA has changed during the formation of the species. This method is now extensively used for define evolutionary relationship. Okay, so from the differing or comparing a different DNA of a different species, we can estimate the how much amount of evolution can be take place. Okay, because of the change in a DNA. Okay. Now, the next is evolution should not be equated with the progress. With the progress, evolution cannot be equated. Okay. In the exercise of tracing the family tree of a species, we need to remember certain things. Firstly, there are multiple branches possible at each and every stage of this process. Okay, different amount of branches are there. Okay, so here you can see that. Okay. A new species has emerged. Okay, new species is emerged, but that does not necessarily mean like the beetle example we have been thinking about, that the old species will disappear. Okay, so in beetle we can see that old species are disappeared and new one is generated. It will all depend on the environmental also. It is not as if the newly generated species are in any way better than the older one. Okay, and it is not one of the things that a better, okay, better species can be generated in a new time as compared to older one. Okay, that is not possible. Okay, it should be possible, but in this case we are not saying. Okay, it is just that a natural selection and genetic drift have together led the formation of population that cannot reproduce with the original one. Okay, it is what, okay, just the natural selection or genetic drift. Okay, just naturally it is selected and as well as genetic drifted, due to which together, okay, both of them work together and lead a formation of a population. Okay, and it will give a formation of a population that cannot be reproduced with the original one. Okay, it have a character but little bit. So, for example, it is not a true that a human beings have a evolution from the chimpanzee. Okay, this is one of the case. Okay, that it is not true that human beings have evolved from the chimpanzee. Okay, rather, both human being and chimpanzee have a common ancestor a long time ago. Okay, a long time ago, both of them, human being as well as chimpanzee, have a common ancestor. Okay, that common ancestor is likely have been neither human or chimpanzee. Okay, the common ancestor which we are saying that have what? Okay, they are neither human or chimpanzee. Also, the first step of separation from the ancestor is unlikely to have a result in modern chimpanzee and human being. Okay, from that also we can say that modern chimpanzee can be seen as well as human beings are there. Okay, so instead, the two resulting species have probably evolved in their own separate way to give a rise to the current form. Okay, both of them have species, both the species have worked by own and probably evolved by its own separately. Okay, both of them, okay, we have given two species, chimpanzee as well as human beings. Okay, both of them have evolved by its own, and in a current period you can see that there is a lot of variation which we are seeing in our human beings also as well as chimpanzee also. Okay, lot of species can be seen in both the organism or species. In fact, there is no real progress in the idea of evolution. Evolution is simply the generation of a diversity and the shaping the diversity by the environmental selection. Depending on the environmental selection, okay, what we are saying, evolution is seen. Okay, depending on the environmental selection, and the generation are diversified. Okay, diversified by its own. The only progressive trend in the evolution seems to be that more and more complex body design have emerged over time. Okay, more and more what, okay, complex body can be seen. Okay, however, again, it is not as if the older design are inefficient. Okay, that doesn't mean that older design which we are saying that inefficient, that is also good enough efficient, but new design are little bit, okay, progressive. So many of the older and simple designs still survive. Okay, older as well as simple design are survived. In fact, one of the simplest life form is bacteria. If we talk about the bacteria, inhabit the most inhospitable habitat like hot spring, deep sea thermal vent, and ice in the Antarctica. Okay, all these are inhospitable habitat. In other words, human beings are not the pinnacle of evolution. Human beings is not one of the pinnacle of evolution, but simply yet another species in the taming spectrum of evolving life. Okay, other species are also working for evolution. They will are getting. Now human evolution. Okay, how the human evolution can be take place. The same tools for the tracing evolutionary relationship, excavating, time dating, and studying fossil. Okay, as well as determining a DNA sequence. Okay, from that also evolution can be seen, and have been used for the studying human evolution. Okay, these all these things are used for studying human evolution, and there is a great diversity of a human form. Okay, in a human form you can see a great diversity, okay, and feature across the planet, so much so that for a long time people used to talk about the human races. Okay, for the long time human beings are talking about the human races, as well as skin color used to be the commonest way of identifying these so-called races. Okay, here, okay, in this time, okay, we are just judge a person by its skin color. Okay, depending on a skin color we can judge it as a one of its race, whether it is African, Indian, Australian, or European. Okay, by which, okay, by its skin color. Okay, by its skin color it can be judged, and it is given a certain on different races. Okay, so were called yellow. Okay, some were called yellow. Okay, here you can see that one by one the one tree is there in which you can see that different species are there. Okay, not only that, regardless of where we have lived for the past few thousand years, we all come from Africa. Okay, where we have came, okay, we have came from where, okay, we will came from Africa, the earliest member of the human species. Okay, earliest member of a human species are what? Okay, Homo sapiens can be traced there. What? Okay, Homo sapiens can be traced there. It is most important that what? Okay, earliest member of the human species Homo sapiens. Okay, earliest member of a human species whom, okay, Homo sapien can be traced there. Our genetics footprint, okay, can be traced back to our African root. Okay, from the African root we can see that, okay, footprint can be seen a couple of 100,000 year ago. Some of our ancestors left Africa while others stayed on. Okay, some of our ancestors has what? Okay, they get separated or migrated from the left Africa. Okay, for what? Okay, they have left Africa and migrated to the other place. Okay, while some of them have lived there, and the resistance spread across Africa. Okay, and in the whole Africa, okay, different resistance has spread, and the migrants slowly spread across the planet. Okay, from the Africa to the West Asia. Okay, so separately migrated from the whole country and planet. Okay, from Africa to the West Asia, and then to the Central Asia, Eurasia, South Africa, East Asia. Okay, all these country, okay, they all of them have migrated separately. Okay, so they traveled down the island of Indonesia, Philippines to the Australia, okay, all these things, and they have crossed the Bering Rain Bridge to the America. They did not go in the single line. Okay, they have not gone to a single line, but so they were not traveling from the sake of traveling, obviously. Okay, they are not traveling for the sake of traveling, but they have migrated for permanently, and they went forward and backward with the groups sometimes separating from each other, sometimes coming back to mix with each other, and even moving in and out from the Africa. Okay, so from this we can see that from the Africa, okay, lot of, okay, ancestors have migrated from to a different countries and places, and they have started that permanent resident there. Okay, so this way, okay, all the ancestor has separated, and due to which, okay, we can see that our species had spread, okay, in all over the planet like all other species on the planet. They have come into being an accident of evolution, and were trying to live their life the best they could, okay, as much as possible.
Evolution of man. About 15 million years ago, primates called Dryopithecus and Ramapithecus were existing. They were hairy and walked like gorillas and chimpanzees. Ramapithecus was more man-like. In Miocene, they also evolved the ape genus Dryopithecus, discovered in the form of jaws, teeth, and humerus from Asia and Europe, and classified as Dryopithecines. It is believed that Dryopithecus represents the ancestral stock from which evolution took place in two directions, one leading to modern apes, gibbons, orangutan, chimpanzee, gorilla, and the other leading to modern man. Instead, on the basis of fossils, one can only discern the anatomical trends and classify evolutionary history into major structural phases, leading towards hominization. Four structural phases in the evolution of man can be recognized. 1. The pre-human phase. 2. The early human phase. 3. The late human phase. And 4. The modern human phase. The pre-human phase. The Australopithecines, or southern apes. 2 million years ago, Australopithecines probably lived in East African grasslands. Evidence shows that they hunted with stone weapons but essentially ate fruits. Some of the bones among the bones discovered were different. The early human phase. Habilines. In 1960, new fossil remains, skull of juvenile jaw, collarbone, parts of 2 hands and left foot, which are about 750,000 years old, were recovered. These bones were attributed to new species, Homo habilis, able or skillful man, who is believed to be the first hominid, who could manufacture simple and better tools or weapons. Bipedalism was indicated from the evidence of leg and foot bones. The brain capacities were between 650 to 800